Okay, here is the test range check on the Horus versus the Taranis. What I will do is I've set up my trusty old Twinstar FPV plane. I'm flying it with a 5.8 gigahertz immersion transmitter. There is a 433 UHF receiver and controller, and then in front I've made this. So we have an X8R receiver with a servo. At failsafe, the servo should move. We should also be able through the camera and look at the LED light from the receiver. The antennas are placed in front in a 90 degree angle. I will cast this airplane out in this area, fly at about 100 meters straight down, and we will see what distance we get before we see a failsafe on the servo and the blinking light. Then we will return with the airplane, rebind to the Taranis radio, switch the UHF module to the Horus, and do the opposite. Then we should see if the Taranis has better range than the Horus. The Horus is set up with external antenna, and it's on the Open TX N359, I think it is, and the firmware on the radio is 20 something. So I need to just go ahead. It's about 3:15 in Norway, and the lights is the sun is going down very fast. So what I'll do now is just pick up my airplane, fly it out, and we'll watch through the OSD the distances we get. Okay.
Okay, then we are up in the air, flying east. You can see the distance from home down in the video, about 660 meters now. The altitude to our right in the window, 124 meters. And everything is going smooth. For this first flight, I picked really the wrong antenna on my goggles, so the video is going to be pretty bad soon. I've flown so much FPV and on 5.8 and other frequencies as well, so I'm kind of used to it. I don't really get scared. When I started out flying FPV, you know, on the first sign of snow I turned around, but now I know how long we can push it until you get into real trouble. But let's just keep on flying and see. We're at about 1300 meters now. I did check at about 1500 meters, and I think I had an RSSI at about 60 or so. Okay, now we just passed 2,000 meters or 2 kilometers. No signs of any RSSI warnings. I was a little stressed for time today too because of the daylight, so I didn't have time to set up a better mix on the servo that would keep it continuously moving so that we could see any jerky movements on it. That was too bad really, would have been interesting. But we can see the green blinking on the receiver. We're at 2.6 kilometers now, and I think this is the first time I heard RSSI low warning, and continued hearing this warning throughout to the end of this flight. We passed 3.2 kilometers now. Actually, the video wasn't that bad, but still, I'm used to flying on 1.3 gigahertz, and it's, you know, I fly 5-6 kilometers without a speck on my in my goggles. It's just perfect. Okay, this was I decided to turn around at about 3.7 kilometers. I had RSSI low, but I never had a failsafe. The reason I turned around is, as you can see now, because of the antenna placement on the airplane, the video would be bad when I turned around. So, full speed back. Avante Boba. In for landing and get ready to test the internal antenna. Okay, then we are on the next flight, which is using the internal antenna of the Horus. What I did here was to fly out. By the way, I switched the video antenna, so it's a little bit better video on this one. Is flying out, and I think after about 1,000 meters now, I decide to check how the Horus is out to the sides and the back. So what I'm actually doing is, as I'm flying, I'm turning the Horus 90 degrees to the airplane to see how it is out to the sides. And in this video we will see failsafes, and the first failsafe we get is when the radio is turned 90 degree perpendicular to the airplane. I also wished I had a camera at the Horus while I was flying. I tried to, but my Xiaomi wouldn't start. So so unfortunately we don't have that, because then we could have heard all the warnings. I seem to recall that the first low RSSI warning was at about 1500 meters now. I don't quite recall when the first failsafe will occur, but we'll see soon. See, I'm down at 68 meters, 70 meters now. So I'm a bit lower than I was on the other antenna at this point. But I was trying to force the failsafe. Remember now, the Horus is facing 90 degrees to the airplane. Okay, that was our first sign of a failsafe at 2.1 kilometers, and that's where it stopped. So what I did now was turn the radio towards the airplane again and waiting for the next failsafe to kick in. And that's it. So no more than actually 300-400 meters further until this next failsafe. And also you see a okay, turning back again. As soon as I turned around, my RSSI was pretty good again. Kind of natural, as at this point there are nothing between the antennas and the transmitter. While I was flying out, there was of course parts of the airplane covering the antennas. So I feel this is a real life test, and I think it passed it actually quite surprisingly good. I did not expect to get these distances on the X8R receiver. I cannot imagine how an L9R would be. So happy for now. I think FrSky did the right thing with the new firmware, the update. There is definitely something has changed, both with the failsafe issue and also in the way it calls out the RSSI warnings, at least. And I don't know if there's been something with the frame loss and the failsafe in general that has been wrong. Okay, thanks for now.